All right, power of powers time. We learned that when we have a to the x power and we raise that to the y power, what do we do with these exponents? We multiply them. So it's x times y. That's a dot, not a subtraction sign. Okay, so let's look at a. If you're confused, if you're not sure, just think about what this really means. All right, 12 to the fifth power is 12 times 12 times 12 times 12 times 12. And you have that 4 different times. So I'll pause the video while I write this out and then I'll restart it. Phew. All right, my arm is tired, my hand's tired. But this, my friends, is why we come up with exponent rules and laws of exponents, because who in the ham sandwich wants to write all these out? But since I did, you can see what happens here. I have 5 12s in each set, and I have 4 sets of them. So I still have 12 as my base number, and I'm going to have an exponent of 5, 10, 15, 20. Okay, so you just want to multiply the exponents. That would have been a whole lot easier than me writing it all out, but I wanted to explain to some of you guys why you get 12 as your base, because your base doesn't change. We've been talking about that for the past couple of videos here. The base does not change. All right, when we look at B, understand that the -2 is not the base. The x is the base. So if you wanted to go ahead right now, you could say, well, x squared to the third power, I can just multiply those exponents and I'm going to get x to the sixth. Most of y'all did not have any trouble with that whatsoever. It's the number that's driving y'all up the wall here, okay? So this is why I call it the rainbow rule, because not only am I dealing with the x squared to the third power, I'm also doing -2 to the third power. All right, so in other words, this is -2 raised to the third power. Well, what does that mean? It means -2 times -2 times -2. -2 times -2 is a +4. +4 times -2 is a -8. So that was your answer there, -8 x to the sixth. Okay, last one, we've got actually a couple different things going on. We have a power of a power, and then we're multiplying that by this m squared. So let's deal with this first. M to the third raised to the third power, that's when I multiply. So I will get m to the ninth. And now my last step is to multiply that by m to the second. Okay, just make sure you realize this is not m to the ninth to the second power. That would be m to the 18th. That's not what this is. This is just a good old-fashioned multiplication problem. M to the ninth times m to the second is equal to m to the, what do you do with your exponents? You add them. So that would be m to the 11th.